All of you all, we are still in part 1. Hopefully today we will be completing part 1 of topic 1, and then we'll be moving on to part 2. Okay, everybody, I hope you'll have your writing books with you all, because today there is a lot of calculation work coming up. Okay, right, everybody, let's get started. Let's continue from where we stopped last time. So everybody, last time we came and stopped at a word called technological convergence. Am I right? Okay, so if everyone can come down to page number, over to page number 17, please, everybody. Can everyone come down to page number 17? We came and stopped over here, technological convergence. Okay, now guys, when we talk about technological convergence, guys, we are talking of a again, I'm sorry, man. We are talking about devices that have multiple features or technologies built into it. Okay, I'll give you guys an example. Think of your smartphone. Your smartphone was primarily built for for calls and SMS. Agree? The phone was primarily built for making calls. That's why it has a microphone and a speaker. It also has a keyboard, so you can send and receive messages. Agree? But the phone has adopted, everyone listening to my words carefully, the phone has adopted so many technologies that today, for you to categorize your phone, it has become quite difficult, right? Can you use your phone for video conferencing purposes? Yes or no? You can. You can basically use your phone as a video camera, isn't it? Previously, guys, if you went for a party, if you went for a wedding, guys, you would have a dedicated device for capturing photographs. Agree? When you went for a party, you would have a digital camera with you. You would have a video recorder with you to capture videos and photographs. In today's world, what do you use? You use your phone, right? You literally use your phone. Okay. Then, guys, let's say, for example, you want to game. Previously, guys, you had a separate gadget. You had a gaming console for playing computer games, isn't it? But today, when it comes to gaming, you do it on your very smartphone. Everybody okay with this? Then, guys, video conferencing. You want to attend a company meeting. Okay, you want to attend a company meeting. Previously, you had to go to a specific location in order to attend that meeting. But in today's world, you can attend that meeting from your very phone, isn't it? Another example, when you wanted to use a torch, you had a separate gadget for that torch, isn't it? You had a separate torch. But in today's world, your phone can be your torch, isn't it? So guys, your smartphone has adopted so many technologies that now categorizing your smartphone becomes difficult. So this is what we call technological convergence. Can you guys read the bold words now? Everybody, bold words, please. When different technologies combine into a single device. Okay, is your smartphone powerful enough for you to even use it as a gadget to work from home? It is, right? It is now powerful enough for you to use it as a gadget to work from home. Okay, can you guys read those examples? I'll load up. Did I show you all the example of the Microsoft Surface Pro? I didn't show it to you all, right? I showed you the part-time batch. Then can you guys check this video out? Now guys online, again, if you have issues with the sound, please do let me know. You all don't need the sound actually. So you guys read the examples I have given you all. Everybody, examples, please. So if you take your smartphone is the best example. Smart TVs, earlier your TV was only used to connect to an antenna and watch channels. But now you have smart TVs, which you can use to access the internet, access online streaming services. You can use it for video conferencing. Okay, keep reading it. Gaming consoles, they were primarily built for gaming applications. But now these gaming consoles will also allow you to use social media on them. They will also allow you to connect to streaming services. Okay, the Internet of Things. Previously, guys, a bulb was only used for the purposes of lighting a room. Now a bulb can be used for many other reasons. The moment you connect to the internet, you can control when it switches on, when does it switch off, the brightness, the colors. Okay, various things can be done with it. Earlier, a watch was only used to tell you time. But now our watches used to tell you how many steps you walk, calories you burnt, your heart rate. Sorry. Okay. Notifications on your phone, all that can be done from your smartwatch. Are you okay with this? Technological convergence, where devices are adopting technologies of other devices. Boys behind, okay, they are. Okay. Okay, this is what we call technological convergence. Now, guys, if you all see the next topic over here, I don't have a lot to tell you all over here. Okay, I just gave you all examples and explained that point. Okay, can you all read the last point? Do you all agree with, not the last point, the last paragraph, boys? Do you all agree with this? Technological convergence, is it bringing about convenience for us? What do you think? It's bringing about a lot of convenience, right? If technological convergence isn't happening, you will be having to carry a lot of devices with you. You will have to charge a lot of devices. You will have to purchase a lot of devices. You will have to maintain a lot of devices, isn't it? But because of technological convergence, everything is happening on one device now. You charge only one device. You buy only one device. You maintain only one device, isn't it? It's bringing about a lot of convenience. Okay. Then guys, the power of these devices are also increasing, right? As the features and technology keeps getting added to a device, its power has to also increase. Okay. So you all agree with this, right? Okay. Makes devices more convenient and more powerful. Okay. The processor of a smartphone keeps getting better and better because of the technologies it's adopting. Okay. Then guys, we come down to embedded systems. Everybody can have a look over there. We all know what embedded systems are, right? Systems built to carry out a specific function. Okay, we spoke about this earlier also. An embedded computer, an embedded system, it's a system built to carry out a specific function. Okay, can you all see the examples that I have given you all below? A washing machine, a smartwatch, a car engine, okay, certain medical devices, a projector, a air condition, a meter in a taxi. These are all examples of embedded systems or embedded computers. Okay, can you guys see the features of an embedded computer or an embedded system? Everybody, can you all see the features over here? Number one is, boys, can you all read it to yourselves? Single function or a limited function. Take a washing machine. It can do different types of washing. I can't remember the names. Anyone remember the names? You have gentle and what else? In a washing machine, you can choose the type of wash you want, right? I can remember only gentle because that's the one we all use. Okay, you have gentle and you have so many other types. Okay, but it has so many types, but it can only do washing, right? If you take a microwave also, it can heat your food in different ways, but all it can do is heating. There's nothing else it can do. Okay, right. It has dedicated hardware. That washing machine works only with a given set of hardware. Okay, it doesn't work with anything else. Okay, you cannot reprogram it. Very difficult to reprogram these devices. Okay, and it's built into one board. There's one board involved in it. Okay, so another word for embedded computers, anyone remembers from O levels we used to use it? If anyone did O level ICT, embedded computers, we had another word because there's only one motherboard or one board. We were calling it single board computers. Very good. We were calling it single board computers. Okay, and then guys, in an embedded system also, it's a computer. There is a microprocessor involved that's going to execute all your instructions. Okay, what do you think about the performance of a processor? Will it be high end or do you think it will be low end for an embedded computer? It's a computer that carries out specific tasks. So do you think the processor needs to be high end or low end? Low end, right? It's carrying out specific tasks. You don't need a complex processor. A basic processor will do the job for you. Are we okay with this? Okay, think about the car DVD, the DVD stereo system in a car, embedded system. Okay, then guys, girls, can we move on to the next one? Firmware. These are words that you all need to know about. Okay, we spoke about technological convergence, we spoke about embedded systems. Now we move on to a third word called firmware. Before I read it to you all, can I explain this to you all, guys? Look at this projector. Now guys, online you all can't see this now. Everybody, when we talk about firmware, guys, you all can't see it now. Students here can see it. I have a projector over here. Okay, I have a projector over here. maybe if I turn the camera, you all can see it. Show video panel, right? Let me see if I turn this way. Right, you all can see the projector slightly. Okay, the projector is over there. Now when I press menu, guys, can you see some instructions have loaded on my screen? Everyone saw this? This is the menu is off now, and now the menu is on. Everyone saw this? These menu instructions are stored on the projector. Agree with me? The brightness, the contrast, the aspect ratio, okay, the amount of hours the bulb has been used, okay, all these settings are stored on my projector. If they are stored on my projector, it means my projector has some sort of storage, isn't it? My projector has some sort of storage built into it to store the settings. Agree? So guys, this storage in my projector, which is storing my settings, is what we call the projector's firmware. Do you guys agree with this? Okay, my projector has a built-in storage to store the settings of this projector. That storage is what we call firmware. Are we okay with this? Okay, right. Now let's read it and see if we can understand it, everybody. Let's read it and see if we can understand it. Right. So everybody, can you all read the bold words now? Embedded systems, not only embedded systems, any computer will have a software called firmware. What does that firmware contain? Can you guys read it? It contains basic instructions that allow that particular system, projector, smartwatch, your laptop, that AC, okay, whatever the device is, in order for it to function. Okay, can you all read that statement again? The firmware is a software which contains instructions in order for your device to function. The device can be a projector, it can be a smart TV, it can be a TV, it can be a washing machine, anything. Okay. So what type of instructions would be there? Read it. Instructions that help the system to start up. It would also have instructions on basic input and output. Everyone okay with this? Right. Now guys, let's, in our own words, let's note down certain points. What type of instructions would firmware contain? Let's start with this projector. Number one, you can tell me. It would contain the, I just told you all. My question is this: what type of instructions would firmware contain? Let's start with this projector. What does it contain? What do we call this? The settings of the projector. So shall we note that down? Okay, everyone, can we note down over here? Settings of a device. Settings of a device. Settings of a device. Give me something else. Everyone look here. I can't see it. Guys online, I'm sorry, you all can't see this, okay? I have to go that side. Everyone saw this? It's right now giving me information about the device. Everyone okay with this? It's giving me information about this device. What is the aspect ratio it supports? What is the serial number? Serial number it doesn't give over here, right? Firmware version. Okay, it's giving me information about this device. This information is stored in the firmware. Everyone okay with this? Guys online, the projector's firmware, guys online, the projector's firmware will contain information about the device, like maybe serial number of the device, model number of the device, the lamp that's being used in the device. We're talking about a projector here, okay? So then you can say information about device. Information about device. Right, let's change the example now, Vilu. Let's say, for example, a car stereo setup. Everyone know what's a car stereo setup now? In the car stereo setup, firmware will have the settings. Firmware will have information about the device. What is the name of the device, brand of the device, model of the device, serial number, things like that. Anything else? In a car stereo setup, is date and time available? In a car stereo setup, is the date and time available? Date and time is available. Date and time in most cases is stored in your firmware. Date and time is stored in your firmware. Anything else? Let's go back to O levels. Everybody, when I connect this projector to my laptop, a small software needs to be installed so that my laptop knows how to work with this projector. I'm repeating myself again. When I connect this projector to my laptop, a small software needs to be installed to tell my laptop how to work with this projector. What do we call that small software? Very good. What did you say? Driver. What did you say? It's a part of system software. Its device driver is a part of system software. Everyone, you all remember this word, device driver? Device driver, every hardware device has a device driver. What does the driver do? The driver will tell your laptop how to work with that hardware device. When I connect this mouse to my laptop, it's a foreign object. My laptop doesn't know how to work with this mouse. But inside this mouse, we have firmware now. Inside this mouse, we have a software called firmware. That firmware will have the driver of this mouse. So that driver gets installed on my laptop. Then my laptop knows how to work with this mouse. Everybody okay with this? After the driver is installed only, my laptop knows how to work with this mouse. In most cases, guys, your device driver is on the firmware. Everyone okay with this? So when you connect the hardware to your laptop, from the firmware, the driver is installed. Now your laptop knows how to work with that hardware device. Everyone okay with this? Can you note down device driver? Device driver. So in your firmware, the device driver will also be there. Give me one more thing. This projector has a certain way of starting up. A car stereo setup has a certain way of starting up. A microwave has a certain way of starting up. When you switch it on, when you switch on the microwave, for example, it might say welcome, it might say Abanzo, Sony, or LG, or whatever. It might make some noises, and now you can start using the microwave. Okay, this project also, as I switch it on, it will say BenQ, and then it will say what? Detecting source or whatever, and then it detects. What do we call that? Telling startup, what do we call it? We have a name for it. BIOS. We call it BIOS, right? We call it BIOS. So BIOS is also stored in your firmware. So guys, these are some of the things that these are some of the instructions you would find inside your firmware. Can everyone remember these? Okay, what would you find in your firmware? Settings of the device, date and time, BIOS. Okay, things like this is what you would find inside your firmware. Everybody okay with this? Is firmware hardware or software? Is firmware hardware or software? It's a software. It's a program that will contain the following. Everyone okay with this? Firmware is a software that contains the date and time of the device, BIOS of the device, information about the device, driver of the device. Okay, right. Keep reading it now. Second paragraph. The firmware in an embedded system is stored within a single chip, or within the single chip it contains. Within the board itself, it's stored. This is different to a general purpose computer where the firmware is stored in ROM. Guys, don't get confused there. Normally, boys, all of y'all, normally firmware is stored in your ROM chip. Okay, but not always ROM. Sometimes in certain devices, they may not use ROM. They might not use a ROM chip. They might use flash memory here. Is it clear? They might use a hard disk. Okay, most cases we use ROM because ROM is very small. In most cases, firmware is stored on the ROM chip. In most cases, but sometimes certain devices might use flash memory. Some devices, hard disk, of course, I don't think anybody uses it because it's so bulky, it's heavy, it has a lot of moving parts, isn't it? Flash memory is a bad idea. I don't think any device will use the hard disk to store firmware. Okay, it's either ROM or flash memory. Okay, keep reading it. The firmware contains BIOS. We already spoke about that. The firmware also contains bootloader. Did we talk about that? Bootloader we never spoke about. So then what is bootloader? Don't tell me. First tell me what is BIOS. BIOS tells your computer how to start up. Then what is bootloader? Now read it. Everyone now read what bootloader is. The BIOS, everyone know what BIOS stands for? Basic input output system. Right, you guys are good with BIOS. What is bootloader then? So BIOS is a set of instructions used to boot up your computer. It tells your computer how to start up. Okay, it initializes the hardware. It gets the hardware ready. It loads the relevant hardware. and gets it ready for the operating system to use. What does the bootloader do? The bootloader is then responsible for loading the operating system. Everybody okay with this? The bootloader is responsible for loading operating system. So guys, here is my question. Will every single computer, listen carefully, every single computer will have BIOS. Will every single computer have a bootloader? Because not every computer has an operating system. There are certain computers that do not have an operating system. Are we good? Everyone, nothing confusing, right? Okay. Guys online, I hope it's making sense over there. So now we know what firmware is also. Okay. So guys, generally, where do we store the firmware? ROM or flash memory. In most cases, it will be ROM or flash memory, guys. Hard disk is not a wrong answer, but I really can't think of any device that would use a hard disk to store your firmware, because hard disk has so many problems, meaning it's bulky, lots of moving parts, slow read write speed. Okay, so I don't think it's a good answer to put hard disk. Flash memory or ROM is ideal. Okay. Then guys, we come to a part you would ask me, why am I repeating it? I'm repeating it because the textbook has asked me to go through it. Okay. When judging the performance of a device, what should you look at? Many of you would have gone through this, or many of you are going to go through this. You all are going to buy your own smartphones. You all are going to buy your own laptops. Then guys, how do you judge whether it's worth the price? How do you judge it? So I'm going to teach you all 5 factors that you all must go through in order to assess, in order to judge whether this device is worth the price. Everybody okay with this? We are going to go through this quite quickly because we have done this in detail previously. Okay, factors that affect the design of a device, we went through it. So guys, number 1 is speed. Speed is directly connected to your processor. 100% processor, not 100%. The RAM also plays a certain role in it. Your storage space also plays a role, but most of it comes from your processor. So guys, can you guys read the bold words there? When I say speed, I'm talking about how quickly can it process instructions? How quickly can it execute instructions? Okay, what's the unit? Hertz. But we don't use hertz. If you go to a computer shop, they'll never give you the computer speed in hertz. They'll give it to you in gigahertz, because hertz is a very small unit. You're going to have a very long number. So normally they'll give it to you in gigahertz. Everyone knows what 1 hertz means, no? 1 hertz means? No. 1 hertz. I just told 1 hertz. 1 hertz means every second 1 instruction can be executed. Okay? But our computers are way more powerful than that. We are dealing in gigahertz, which is 1 gigahertz would mean how many instructions? 1 billion. We are dealing with gigahertz, 1 billion instructions. Okay? All right. Can you guys just read it? Because I'm not going to go through this. Okay? A faster processor means a higher operating speed for your device. Okay? Then guys, do you all remember the cause? Boys over there, are you with me? Okay? You all remember the cause? Okay? More cores means what? More tasks can be done. What do you say? At the same time, simultaneously, right? When you have more cores, the same one job can be shared among multiple cores, isn't it? Instead of getting 1 person to do the job, you have 4 people to do the job. So that one job is being handled by 4 people at the same time. Obviously, it's going to be done a lot faster. Okay? Right. Why don't you all read it, guys, and then I'll move on. I'll be moving in a minute. Okay? So when you are purchasing a device, guys, factor number 1 is check its speed. When I say speed, immediately you will go to the processor column. What is it? CPU performance. Everyone okay with this? Okay. Factor number 1 is check its processor. Are we all good? Give me examples of processors in today's world. Core i9, i7, i5, i3. Then add to it. Not enough seeing the processor, now you have to also see the generation. Very good. Second generation, third generation, fifth generation. You have to also look at that. In addition, you must also look at the number of cores. Very nice. You have to also look at the number of cores you are dealing with. Everybody okay with this? Right. The second factor is, guys, look at the capacity. Okay, the amount of storage this device can hold. Under capacity, guys, two things you will look at. What are they? Everybody, under capacity, two things you will look at. Storage and storage is what? Not type of, okay, type of storage, okay. Under capacity, two things we will look at. So when I say capacity, tell me what hardware am I talking about? Hard drive. Only hard drive? Am I talking only about the hard drive? Okay, am I talking only, what did you say? RAM also. Because higher RAM means what? You can have more programs opened at the same time, isn't it? And when you have a large storage, you can have many files stored on your device. Is it clear? We have storage and memory. Memory is RAM, storage is your secondary storage, your hard disk or your SSD. When you have a high memory, you can have many programs opened at the same time. When you have a high storage, you can store a lot of files on your device. Capacity covers both of them. Okay, so guys, when you are purchasing a smartphone, you will look at two things. When they sell a phone, what do they mention? iPhone 16 Pro Max, and then what do they say? 16 GB, 256 GB. What is the 16 GB? 16 GB is your RAM capacity. 256 GB is your, not ROM, your internal memory. They'll be using flash memory. In smartphones, they use flash memory. Everybody okay with this? When you're buying a laptop also, shall I give you all real life examples? Oh, guys online, you all have given me the answers. Just now only I saw it. Everyone look here. When you're buying a laptop, let's go to laptop prices Sri Lanka. Okay, so let's go to laptop.lk. You will notice, guys, in the title itself, they'll mention the RAM and internal storage. I'll just go with Lenovo. Okay, so when you go here, they have mentioned the processor. Now they should also mention the, doesn't matter, let's open it up. So it's a i3 processor over here, guys. These are the most important things. i3 processor, 512 GB SSD, 8 GB RAM. Everybody okay with this? So laptops, these are your most important information. Now when you come down, they will tell you the generation and the speed. So when you come down over here, have they mentioned the number of cores and all that? They haven't mentioned it over here. Everyone over here? I didn't understand. They have mentioned the speed of each core, something like 4.5, 3.3, 1.6, something like they have mentioned. Okay. So everyone, when you're purchasing a laptop, guys, you look at your processor, your capacity, which is your RAM, and your secondary memory. Then, guys, third, what do we look at? Portability. Give me words that support portability. Weight, size. Your weight and your size. There are other factors also, connectivity and all matters. But most important is what? Weight and size. Okay, then battery life, connectivity, durability, what you call setup, those also come. But the most important is weight and size. Okay, right. Can you guys read portability? Everyone read portability, please. But sometimes, guys, you will purchase a device without bothering about portability. Okay, if you're a video editor, guys, you don't care about portability. You want a desktop, isn't it? So portability really doesn't matter to you. But if you're somebody, for example, you're an engineer who's working on site, portability matters a lot to you. Okay. If you're an influencer, for example, portability matters a lot for you. Okay. Right. And finally, guys, we have something called bandwidth. Not finally, we have one more. Bandwidth is how fast can this device transfer data. Can you guys read the bold words there? Amount of data that can be transmitted over a network or in a connection in a given amount of time. We usually use Mbps, megabits per second. Everyone okay with this? All of you all, some of you all at home, you all have a fiber optic connection. Fiber optic SLT promises how much? 1 Gbps, no? If I'm not mistaken. Am I wrong? 100 Mbps. Sorry, my bad. I also can't remember. SLT makes a promise of 100 Mbps. Okay. But the problem is what? Your laptop Ethernet port or your laptop's Wi-Fi driver can support maximum 25 Mbps. You get it? So even though SLT is offering data to you at 100 Mbps, your device can only deal with data at a speed of 25 Mbps. Are we okay with this, guys? So another factor is your bandwidth. How much of data can your device accommodate in a second? Okay, can you guys read that? In terms of digital device performance, higher bandwidth means the device can send or receive more data in a shorter period of time, leading to faster downloads and uploads, smoother video streaming, quicker web browsing. Low bandwidth can cause high latency, lagging, buffering. Okay. And finally, guys, you will be looking at power efficiency. How much of electricity is this device going to consume? Okay, you will not ask that question, rather you will ask how long is the battery life. Okay, everybody, because many of you all are looking for portable devices now, so then how much of electricity it consumes is not your concern. Your concern will be how long is the battery life. Can I use it for an entire day on a single charge? Okay, that will be your concern. Okay. Okay, everybody, shall we go from the top again? To assess the performance of a digital device, what are some of your factors? The most important one, give me below. Speed. Then your capacity. Then portability, bandwidth, power, efficiency. Okay. Right. Guys, we will not do any questions right now. We will do it after the break. Okay. So with that, guys and girls, we come to the end of part 1. We are now going to move on to part 2. Everybody, can you all take part 2 out? Okay. Guys online, I'm sending part 2 to you all now. You have part 3. Okay, everybody, can you all open up page number 4 and come over here? Everybody, we know what processing means now. Can you all tell me again what processing means? Converting data to information, input to output, instructions to information. Everyone know what processing means now, right? Now we all know what processing means. Converting your input to output, instructions to information, data to information. That's what processing means. Right. Can you guys read the first paragraph? Your device needs to process different types of data, text, numbers, sounds, images. All data that is processed by a device will ultimately get converted into something called binary. Let's assume you guys know nothing about binary here. Okay, everybody. Maybe you all have learned it in O levels. Okay, but I'm going to assume you all know nothing about it. So I'm going to start from 0. Okay, from the basics, I'm going to start. This is the only type of data that a device is able to process. What did I tell you all? Your computer can only deal with data in what format? Binary format. So basically, when you give input to your computer, that input is converted into what? Into binary format. What is binary? Let's see what binary is now. Read the next paragraph. Humans process data in analog form. We deal with data in analog form. Okay, we can understand sound, we can understand what we see, but our computer only deals with something called digital form. That digital form is 0 and 1. Another word for 0 and 1 can be binary. Everyone, did you understand what I just told you all? As humans, we understand sound, we understand visuals, okay, we understand letters, we understand numbers, we understand all this. All this comes under analog form. The computer understands only 0 and 1, which you can call binary or you can call it digital form. Are we okay with this? The computer understands only 0 and 1, which we can call binary or digital form. Right. Digital data is binary. It has only two values, 0 and 1. So now guys, we are going to learn how do we convert our numbers. What are the numbers we use? We start at 0 and go all the way up to 10. 9, right? We go up to 9, isn't it? From 0 to 9. All our numbers are formed using digits from 0 to 9. Agree? All our numbers are formed using digits from 0 to 9. So the number system that we use, Shahad, all of you, everyone, the number system that we use, what do we call it? The decimal number system or Denary number system. Everyone okay with this? Can you remember those two words? The number system that we use from 0 to 9, we call it Denary or decimal. The computer's number system, what do we call it? We call it binary. Everyone okay with this? The computer's number system contains of only 0 and 1. Contains of only 0 and 1. Okay, right. Now everyone, can you all take your writing books out, please? And guys, you all can't use calculators here. Strictly prohibited, no calculators. Okay, so can everyone take your writing books, please? Everyone, can you take this down? The binary number system, boys, girls, the binary number system has only two digits, 0 and 1. That's it. Okay. Everybody okay with it? The binary number system contains only two digits, 0 and 1. Okay. So now guys, what we need to learn is converting a decimal number to binary. Okay, some of you all already know this, some of you all will have no clue at all. Those who did local, anyone local O levels here? Oh, so then this is nothing for you all, isn't it? You all have done this, right, in locals? So Edexcel and Cambridge wouldn't have done this. You have done it. How do you do it? In the school you all learned of this. Okay, right. So again, I'm assuming you all know nothing about it. I'm going to assume you all know nothing, so we're going to start from 0. So guys, I'm going to give you a decimal number. We'll take the number 25. This number 25, I want to write it in binary format using ones and zeros only. Okay, so everybody, what do we do over here? We take 25. we take 25 over here, okay, and I want to convert it into binary format using ones and zeros. So the method we follow is we start dividing it by 2. Okay, you start dividing this by 2. So what you do is you take 25, everyone, and you divide it by 2. So in 2, guys, how many 2's you have? You have 1. In 5, how many 2's you have? You have 2, and there is a remainder of 1. Everyone, again, in 12, how many 2's do you have? 6. You have a remainder of 0. You have a remainder of 0. Everybody online okay with this now? You have a remainder of 0. In 6, how many 2's do you have? 3. And there is no remainder at all, right? Anyone confused about this remainder thing? Akash, okay there? Okay. In 6, there is exactly 3 2's. There is no remainder at all. Okay, so I put 0. In 3, how many 2's do we have? In 3, there is 1 2, and there is also 1 remainder, right? So I put there is 1 2, and there is also 1 remainder. Okay with this? Now guys, follow the arrows. Follow the arrow. You go from left to right, and then from bottom to top. So what do you write your answer as? I told you from left to right now. So you write what? 1 1. Now go up. 0 0 1. Everyone okay with this? This is 25 in binary format. Okay. You know why I put 2 at the bottom? To indicate this is a binary number. Okay. Otherwise users might think it's 11,001. So you put a 2 to say no, this is not 11,001. This is 11001. Are we good? Right. We'll do one more example and then we are going to move away from here. Say for example, guys, I give you the number 75. When I give you the number 75, guys, and I've asked you to convert it into binary format. Okay. So then what do you do? Again, guys, same method. You take 75 and start dividing by 2. In 7, how many 2's? In 7, we have 3 2's. No, 3 times 2 is 6 now. We have 3 2's and there is 1 remainder. No, 3 times 2 is 6 now. We want 7 now, so that 1, I'm going to bring it here. This becomes 15. In 15, how many 2's do we have? In 15, how many 2's do we have? We have 7. 7 times 2 is 14, right? We have 7 2's there. So 14 to 15, how much of remainder? Remainder is 1. There is 1 remainder. 7 times 2 is 14 now. We wanted 15. Then again keep dividing. 37 is a big number. Take 3. In 3, how many 2's? You have 1. Any remainder? 1 remainder. Bring that 1 next to 7. In 17, how many 2's? 8. 8 times 2 is 16, no? You have 8. Remainder is 1. We want 17, no? 1 remainder is here. In 18, how many 2's do we have? We have 9. Remainder is 0. In 9, how many 2's do we have? 9 times 2 is 4. That's 8. So there is 1 remainder, no? 1 remainder. In 4, how many 2's do we have? We have 2. Remainder is 0. No remainder. Then in 2, in 2, how many 2's do we have? We have only 1. Again, no remainder, 0. How do we write our answer? Left to right, top to bottom. Are we okay with this? Left to right, bottom to top. Sorry, not top to bottom, bottom to top. So what does your answer become? Left to right is 1 0. Then bottom to top you have 0 1 0 1 1. 0 1 0 011 base 2. Okay. Yes, right. Okay. Then guys, if you can convert this way, you also have to be able to convert the other way from binary to decimal. That should also be possible for you. Okay, can you get down that heading? Converting from binary to decimal number. Everyone okay with this? Converting from binary to decimal number. Things are a bit different over here. So I'll give you all a binary number, guys. Okay, I'll give you all a short binary number. The binary number I'm going to give you all is 1001. Okay, everybody, this is the number I'm going to give you all, 1001. Now, guys, when I give you such a number, guys, what you have to do is you have to create something called position values. Okay, you have to create something called position values. When creating position values, guys, you will start from the right hand side. Are we okay with this? You will start from the right hand side, and from the right hand side this will be equal to 2 to the power of 0. Are we okay with this? The right hand side value, the value on the right most, what do you say, the right most hand or whatever, the one at the right end has a position value of 2 to the power of 0. Then the one after it will have a value of 2 to the power of 1. The one thereafter will have a value of 2 to the power of 2. The one thereafter will have a value of 2 to the power of 3. Now guys, girls, can you all tell me 2 to the power of 0 is equal to how much? 1. 2 to the power of 0 is equal to 1. 2 to the power of 1 is equal to 2. 2 to the power of 2 is equal to 4. 2 to the power of 3 is equal to 8. You know what 2 to the power of 3 means, right? 2 times 2 times 2. That's equal to 8. Then what do you do, guys? You multiply and add them, isn't it? You multiply your binary value with your position value. Okay, so what do we have now? We have 1 times 1 multiplied by 8. You understood this, right? I multiplied these two. Okay, 1 multiplied by 8 plus, go on, 0 times 4 plus 0 times 2 plus 1 times 1. Understood, right? Sharif, okay there? I'm multiplying by my binary value with the position value and then adding them all together. So here we have 8, 0, 0, 1. Add them all together. What do you get? You get 9. Base is how much? This is 10 because it's a decimal number. Base is 10. Okay. Let's do another example, a slightly longer number. One, 0, 0, 1, 1, 0. A slightly longer number this time. Okay, base 2. It's a binary number. I want you to give it to me in decimal format. What did I tell you all to do? Step number 1, give position values. We start from which side? We start from the right side. Position value will be what? 2 to the power of? You guys are still writing. Okay, so what do we do here? Start giving your position values. This is 2 to the power of 0. This is 2 to the power of 1. This is 2 to the power of 2. This is 2 to the power of 3. This is 2 to the power of 4. This is 2 to the power of 5. This is 2 to the power of 6. Are we okay with this? We know 2 to the power of 0 is equal to 1. This is equal to 2. This is equal to 4. This is equal to 8. This is equal to 16. This is equal to 32. This is equal to 64. Now multiply your binary value with your position value. Okay, shall we ignore the zeros? Because 0 multiplied with anything is 0, right? So we can ignore the zeros. Okay, everyone, you can ignore the zeros because anything multiplied with 0 is going to give you 0. So I'll only focus on the ones. So 1 times 64 plus 1 times 32. No need to type, no need to write 0 times 16, it's anyway 0. Plus 1 times 4 plus 1 times 2, and the 0 I'm going to ignore. So what do we get here? 64 plus 32 plus 4 plus 2. So that gets you 68, 70, 102, no? 102 base 10. The base 10 indicates it's a decimal number. Okay? 126, no, that something must have gone wrong, I think, on your side. Anyone wants me to do one more example, or shall we move on? Everybody? Oh, zeros, because 0 multiplied 0 times 16 is 0. 0 times 8 is 0, so we don't consider the zeros. Then boys, girls, everyone, now that you all know how this works, we are now going to look at the next part, which is measuring computer memory. How do you measure the storage of a computing storage device? Okay, how do you measure it? There are two ways of measuring it. You can measure it using the decimal number system. You can also measure it using the binary number system. Everybody okay with this? So guys, girls, can I move down over here? So guys, can we now note down over here? Measuring computer memory. Measuring computer memory. Okay. Now guys, one bit is the smallest unit of computer memory. We have things smaller than this also. We have a nibble and things like that. But for now, I'm just going to say 1 bit. Okay. Now, all of you all, 1 bit is the smallest. But the smallest measurable is 1 character. Agreed? The smallest that we can measure is 1 character. The letter A, the letter B. Every single character in your computer takes up a space of 8 bits. You get what I said? The smallest unit is 1 bit, but the smallest that you can measure is 1 character now. 1 character takes up a space of 8 bits. You guys get my point? Okay. So now I'm going to add a confusing point over here. Okay. 1 character such as A or B, takes up a space of 8 bits. Everybody okay with this? Okay. So for example, if I were to type platinum into notepad, how much of space would that file take? PLA. How many characters? 8 characters. PLATINUM. 8 characters. 8 times 8 will give you 64. Isn't it? You'll understand that, right? Platinum is 8 characters. Every character is taking up 8 bits. Okay. So 8 times 8, it's going to take up 64 bits of space. A notepad file containing the letters platinum will take up 64 bits. Okay, everybody. Now let me tell you all one more thing. Yes, 8 bits with a simple B, 8 bits is equal to 1 byte. Are we okay with this? Okay. Right. Keep this in mind, and now there is a note that I want you all to take. Computer memory can be measured using the decimal number system. Can be measured using decimal numbers, can also be measured using binary numbers. We have a small problem when it comes to binary numbers. Everybody okay with it? Can you all note this down now? When measuring numbers using the binary number system, we have a note over here. When measuring computer memory using the binary number system, we can only use numbers that are an exponent of 2. We can only use values that are an exponent of 2. This is a rule that you have to keep in mind. Okay. In the binary number system, all of you, Sharif, all of you took it down. You can only use numbers that are an exponent of 2. I'll tell you what this means. Okay. You can't use any other numbers. Okay. So everybody, 2 to the power of 0 is how much? 2 to the power of 0 is 1. So in the binary number system, can you use 1? Why no? 2 to the power of 0 is equal to 1 now. I just told you, you can only use numbers that are an exponent of 2. So 1 you can use because 2 to the power of 0 is 1 now. So 1 you can use. 2 to the power of 1 is equal to how much? 2. So you can use 2 also. 2 to the power of 2 is equal to 4. You can use 4 also. 2 to the power of 3, how much? 8. You can use 8 also. 2 to the power of 4, 16. You can use 16 also. 2 to the power of 5, 32. So you can use 32 as well. 2 to the power of 6, 64. You can use 64 as well. 2 to the power of 7, you can use 128 also. 2 to the power of 8, 256. 2 to the power of 9, 512. And 2 to the power of 10, 1024. You can use 1024 as well. Okay, everyone, can you take down this note? I have something to show you all there. So remember this rule, okay? When using the binary number system, you can only use numbers that are an exponent that have a, you can only use values that are an exponent of 2. Okay? Now guys, you all need to, okay? Now can you break your page into 2 columns, guys? Everyone took this down? Break your page into 2 columns, okay? On one side you will have your decimal number system. On the other side you will have your binary number system. Decimal number system. Decimal number system. And on this side you have your binary number so everybody, what did we learn, guys? 8 bits is equal to what? Everyone took this down, no? I'm moving down. Okay, I'm moving down. So everybody, we learned that 8 bits is equal to 1 byte, capital B, 1 byte. Everybody okay with this? 8 bits is equal to 1 byte. Can I write the same thing in binary? In binary, do we have an 8? We don't have an 8 in binary, no? So we can't write it, isn't it? 2 to the power of 3 is how much? So why you said no? Everybody, in the binary number system, is 8 there? In the binary number system, do we have an exponent that has a value of 8? We do have. 2 to the power of 3 is 8. So you can use 8. You can say 8 bits. In the binary number system, you can say 8 bits because 2 to the power of 3 is equal to 8. So you can use 8. So everyone, what do I do over here? I'm going to say 8 bits is equal to, can I say 1 byte is 1 there? 2 to the power of 0 is 1, right? So I can say 1. 1 is accepted. 1 byte. No problem so far. Now guys, in the decimal number system, when you put 1000 bytes together, it gives you 1 kilobyte. Are we all okay with this? When you put 1000 bytes together, you get 1 kilobyte. Okay. Now come to the binary side, Velu. In the binary side, can I say 1000 bytes? Do we have 1000 in the binary number system? We don't. What's the closest we have? 1024. Everybody okay with this? So in binary number system, we don't say 1000 bytes, we say 1024 bytes. Over here, we say 1024 bytes is equal to 1. Can I say 1? I can say 1. Now, guys, can you say kilobyte here? If you say kilobyte, you're confusing the user. In decimal number system, you say 1000 bytes is 1 kilobyte. And here also, if you come and say 1 kilobyte, you're confusing. So what do we say? We say 1 kibibyte. Everybody okay with this? We say in the binary number system, we say kibibyte. So when I say 1 kibibyte, you immediately understand how many bytes? 1000 or 1024. You understand it's 1024 because kibi means binary. In binary, we don't have 1000. We have only 1024. Okay. So here we say 1 kibibyte. Okay. Then guys, if you were to put 1000 kilobytes together, 1000 capital K, capital B, you will get 1 megabyte. 1 megabyte. Okay. But in binary, we don't have 1000, we have 1024. 1024 kibibytes, capital K, simple I, capital B, is equal to 1 maybe byte. Are we okay with this? 1024 kibibytes is equal to 1 maybe byte. Then in the decimal number system, 1000 megabytes, capital M, capital B, will give you 1 gigabyte. In the binary number system, we say 1024 maybe bytes, capital M, simple I, capital B, gives you 1 gigabyte. Thousand gigabytes is equal to 1 terabyte. Here it becomes 1024 gigabytes is equal to 1 terabyte. And we can keep going on to petabyte and all that, but I'm gonna stop it here. Okay, can everyone get this down? You all need to learn this order, okay? Bits, bytes, kilobyte, megabyte, gigabyte, terabyte. You all have to learn this order, okay? Without this order, doing any of the calculations becomes difficult. Not difficult, becomes impossible, okay? You have to know this. Okay, you took it down. Shahada. Okay. Everyone okay with this? So now we need to learn how to convert between units. We now need to spend some time over there. How do we convert between different units? Okay. Guys online, please make sure you all have taken this down. Right, everybody, guys, girls, all of you, I have we stopped over here comparing the decimal number system and the binary number system. Guys, can you look over here and tell me what are the units that are common between decimal and binary? What are the common units? It exists on both sides. Bits and bytes. Everyone agree with that? Can we put a star over there to indicate that it's similar? Okay, bits and bytes exist on both sides. Are we all okay with this? Between binary and decimal, the common unit is either bits or bytes. Boys behind, are you all with me? Okay, put everything else away. Okay, bits and bytes are the common units between these two number systems. Now guys, let's take down this converting from a big unit to a small unit So everybody, if I were to give you an example, let's say for example I was to ask you, give me 2 gigabytes in megabytes. Okay, so I want 2 gigabytes I want it converted into megabytes. So guys, we already did this when it came to processor speed. When we convert from a big unit to a small unit, we multiply, isn't it? So everybody, where we are? We are 2 gigabytes. We are gigabytes. We want to go up to megabytes. So you multiply here. By how much? By 1000. So now you get to megabytes now. So you have to. So now your answer is, okay, 2000 megabytes. Everyone saw this? This is how you convert from a big unit to a small unit. You simply multiply here. Let's take it to the next level, guys. I want to convert 2 gigabytes. I want to convert 2 gigabytes to bits. I want to convert 2 gigabytes to bits. Okay. Now, how does this work, guys? Again, you can clearly see we are going from a big unit all the way down to a small unit. Okay. So how does it work? So everyone over here, 2 gigabytes. From here, what do? We have to go down to megabytes, 1000 megabytes. From here, where do we go? 1000 kilobytes. Guys, if you are looking, if you all can look at your table, that will be good. You all can see slowly by slowly, I am going up until I reach bits. So from gigabyte, everyone can look at my screen. Look at my screen, please. From gigabyte, I came to megabyte. From megabyte, I'm going to kilobyte. From kilobyte, I'm going to bytes. And from bytes, I'm going to go to bits. You guys saw it, right? Step by step, I'm climbing up. Okay. So now what do? 1000 kilobytes. Then 1000 bytes. Now I get to bytes. I still have not reached the end. Now from bytes to bits, look at your table and tell me. You multiply by 8. Everybody okay with this? You multiply by 8. So now you multiply by 8. 8 bits. Now you have reached the end. Okay, now you have reached the end. So now what do? You don't have a calculator. What you can do is 2 multiplied by 10 to the power of how many zeros? 3 zeros here, 3 zeros here, 3 zeros here. That gives you a total of 9 zeros, right? So 10 to the power of 9. Okay, multiplied by 8. You can keep your answer like this, perfectly fine. If you want, you can also write it like this. 16 times 10 to the power of 9. Everybody okay with this? This is also perfectly all right. Remember, no calculator. Okay. So everybody, how do we do this? Now I have changed the number system. I have now gone into the binary number system. Okay. So 7.5 gigabytes. How does this work? So everybody, we are going from a big unit to a small unit. Now guys, we don't use 1000 in the binary number system. How do you know I'm using binary number system? By looking at the unit, right? When you see GB byte, you know it's binary here. So now we say 1024. 1024 may be bytes. Then again 1024 key B bytes. Then again 1024 bytes. Have we reached the end? We have reached the end. Okay, you can keep your answer like this, completely fine. Or if you want, you can simplify it into 7.5 times 1024 to the power of, how many are there? 1, 2, 3 cubic, right? And you can put the units as bytes. Are we all okay with this? Okay. Then let's see the other way around. Now we are converting from a big unit to a small unit now. So it's multiplication. It's quite easy here. What if you are converting from a small unit to a big unit? Then division comes into play. That confuses some of us. Okay. So we'll have a look at that now. So everybody, I'm moving up now. Over here, guys. Converting from a small unit to a big unit. Converting from a small unit to a big unit. So I'll give you guys the example of 8.75 times 10 to the power of 9 bytes. I want the answer in gigabytes. Are we okay with this? I'm giving you all a question in bytes. I want the answer in gigabytes. Okay. So now we are going from a small unit. We are going all the way up to a big unit. Okay. Done. So what we basically do is (8.75) times 10 to the power of 9 bytes divided by, we are using the decimal number system now. So we use, from bytes we go to bytes, we have kilobytes now. From bytes we go to kilobytes. 1000, right? Decimal now. 1000 kilobytes. Again we divide by 1000 megabytes. Again we divide by 1000 gigabytes. Now all of y'all, you can keep your answer this way, or you can write your answer like this. 8.75 times 10 to the power of 9 divided by how much? 10 to the power of 369, isn't it? Divided by 10 to the power of 9. And what will your units be? Gigabytes. Some of y'all might be a little confused. This entire area, I brought it here. Are we okay? This entire area, I brought it here. Are we okay? That's what has just happened now. Okay. Everybody, 7.75 times 10 to the power of 8 bits. I want it in TB bytes. Okay? You're in bits. I want you to go to a much larger unit. So obviously we have division involved over here. And we are using the binary number system. So you won't be dealing with thousands. You will be dealing with 1024. Okay? One second, guys, online. Let me take attendance. So now 7.75 times 10 to the power of 8 bits. You can keep dividing until you get to TB bytes. 1008, right? Very nice. Everyone, not 1024. From bits to bytes, it's 8, isn't it? From bits to bytes, we go by 8. Okay? So here we have 8 bytes. Okay? Then keep dividing. From bytes, we go to KB bytes. That is 1024. 1024 KB bytes. Then again, we divide and come to 1024 maybe bytes. Then again, we divide and come to 1024 GB bytes. Then again, we divide and come to 1024 TB bytes. You can keep your answer like this, perfectly all right, because you don't have a calculator. Or if you want, you can simplify it for the examiner by writing it like this. 7.75 times 10 to the power of 8 divided by 8 times 1024. 1, 2, 3, 4 to the power of 4. And your unit will be TB bytes. So guys, if you all are confused how this happened, this entire region, I brought it here. This entire region, I brought it here. Okay, everybody? That's what basically happened over here. Sounds good, everyone? Okay. Right, guys, can we now stop at this point and can we go back to part 1? I want to do a few questions from there and then come back to part 2 again. Can we all go back to part 1 and do a few questions from there? Guys, girls, everybody, can we go on to topic 1, part 1 area? Topic 1, part 1. So everybody, if everyone can come down to question number this 7, I'm a bit lazy to work on it. It's a long one. Can we come down to, yeah, we can do question number 8 now. Everybody, question 8, please. Question 8, please. Part 1. Everybody, we are in part 1, not part 2. We are all in part 1. Anika is training to run a marathon. She wears a device on her wrist that helps her with her training. Here is a drawing of the device. This device obviously looks like a what? Smartwatch. This device demonstrates technological convergence. This device has adopted technologies from other devices. That's what you call technological convergence now. Okay, so what are your benefits? Explain 2 benefits of technological convergence in this device. Normally, what's the primary function of a watch? To tell you time now. This watch can do more than that because it has adopted technologies of a health monitor, fitness tracker, okay, navigation aid maybe. Okay, so sorry. Okay, what's the convenience here? Convenience is true, but you don't get marks until you tell me what it means. What's the convenience here? Brings about a lot of convenience to Anika. Now go on. How? How does it bring about convenience? It has made life a little easier for her. How? Yeah? So you're telling me it has a navigation aid, it'll make easier for Anika to find her way if she gets lost. I didn't ask in terms of that. I didn't ask in terms of the benefits of its features. I'm asking benefit of technological convergence, of putting these technologies all together. What's the benefit? Exactly. So Yetum, you also have said there are certain financial benefits. Can we complete convenience? Now she already said it. No, we'll complete convenience and we'll talk about finance. What did you tell? Doesn't have to carry. Now she's doing a marathon, right? Imagine carrying multiple devices for a marathon. Now you see the convenience here. She only has to use one device here. That one device can calculate the number of her speed, number of steps taken, her heart rate, and her current location. Normally, to calculate her location, she might need a navigation aid. Then for number of steps taken and kilometers walked, she might need a fitness tracker, isn't it? But all this is built into one device known as her smartwatch. Okay. So let's start off. This device brings about a lot of convenience since, and we'll start writing them. Okay. This device brings about a lot of convenience since this one device can replace many devices like since this one device can replace multiple devices like a navigation aid, next fitness tracker, don't put comma, we'll put and, like a navigation aid and fitness tracker. Okay, then somebody spoke about finance. She can save on purchasing cost. Instead of purchasing multiple devices, she purchases only one device. Okay, she can save on purchasing cost. She can save on purchasing costs since we can say she can save on purchasing costs because instead of buying multiple devices, she is buying one device that has the technology of other devices. Because instead of buying multiple devices, she is purchasing only one device that contains the technology of many other devices. That contains the technology of many other devices. Under convenience, can we talk about charging? When it comes to charging, how many devices does she have to charge? Only one, instead of charging many devices. When it comes to portability, she has to carry only one device instead of multiple devices. Energy consumption, instead of in terms of maintenance, she has to maintain only one device. Okay, very true. Right. Let's see if we can do another one. Everyone, come on, boys. Okay, we are moving down. Everyone done with this? Sarah has purchased a smart TV. The features of the TV allow her to browse the internet, deal with email, and use interactive media. Identify the statement that best describes Sarah's TV. The TV is an example of technological convergence. Agree? This TV is a good example for technological convergence. That answer is possible. They have told you to select the best answer now, so keep reading. It is safer to browse with the TV than with a laptop. Makes absolutely no sense at all. The TV is an example of parallel development. We never learned anything called parallel development, right? We never ever learned anything called parallel. That answer is out. Sarah can store her email messages on the TV. She could, but that doesn't best describe the TV, right? From these answers, the one that best describes the TV is answer A. So here we mark answer A. Website traffic statistics. One second. Come down to question 12 below. Everybody, question 12, please. Sometimes when Sarah turns her TV on, a message is displayed saying that the TV firmware is being updated. The firmware is being updated, okay? So even my smartwatch, guys, its firmware regularly receives updates. But this projector's firmware, do you think it gets updates? It doesn't get updates, okay? So her TV, apparently, the firmware does get updates. State one type of memory used to store firmware. ROM or flash memory, hard disk, but let's avoid that answer. Let's go with ROM or flash memory. I'll go with flash memory. Flash memory. One function of a TV's firmware is to store the operating system. Now in laptops and all, that's not the function of firmware. In laptops and all, operating system is stored separately in your hard disk. But in this TV, the firmware contains the operating system. Give two other functions of firmware. Sorry? One second, what did you say? Information about the TV, device driver of the TV, if you want to connect the TV to your laptop as external display. Very true. Go on. Information about TV like serial number, brand, model, okay, things like that. Information about TV, in brackets, just give a few examples. Okay. Brand, model. Okay. Then what did you tell me? You said information. You said device driver. device drivers. Something else? Date or time, or date and time. Something else? BIOS settings. Okay. You can mention BIOS over there. The last question in this paper, guys. Boys, the last question on this paper. Question number 14. Organizations use a range of digital devices and IT systems. State 2 factors that can be used to assess the performance of digital devices. You can first, most important is look at its speed. Then you look at its capacity, RAM and internal storage. Then you look at its portability. And then you have its bandwidth, also power consumption or power efficiency.